Yes, last time I could start recording somewhere in between. So now I have started recording. Yeah. Okay. So what I have done is I have uh, prepared a playlist of all the videos, and around 2 videos I have added more in that. So these are all the videos. This is also an excellent video. Uh, this this channel Wired. This channel's name is Wired, and they do this sort of exercises. So here in this video, around a half an hour video, a computer scientist explains machine learning in 5 different levels. So first, they call a kid. Yeah. What is it? It's humans. And how do you? So she is explaining to a kid what machine learning is. So then she will explain to a school-going boy. Then she will explain it to a college-going kid. Then ultimately another scientist in a yeah, I think computer scientist only. So who has not exactly uh, worked in the same domain. So this is very nice to be able to understand at different levels and to be able to listen to these explanations. So I've included that as the first video. Then the second is what we have seen already, a very brief outline of all the models. Well, yeah. So similarly, I have added everything we saw in the earlier class. So I think neural networks video we had seen, the first video. I have added 2 more in neural networks by the same person, 3 blue, 1 brown. Yeah. Then today we will be looking at clustering. Clustering was not discussed last time. So we will see a couple of videos in clustering, discuss the basic concept, then come back to decision tree and solve a problem. So this is the problem, decision tree problem or decision tree data we have. So step by step, we will try to prepare a decision tree. Yeah, how exactly that is to, that is to be done. So there are a different ways, of course. In data science, there are different ways to do anything and everything. But we'll see a simpler way of preparing a decision tree based on this data. Yeah. So that is the agenda for today. So let's have a couple of videos on clustering, this one and these two. Yeah.
Hello everyone, my name is Arham. In this video, we will look at the fundamental concept of clustering and
Is the sound audible? The sound from video is audible?
Yes, sir.
clustering.
But not clear little bit. You just repeat it.
Okay. Yeah. Network shows a different color than when it is good. When it is good, it shows green. Now it is showing blue. Just a second. Okay, now my mobile hotspot is also there. Let me connect it to that.
Hello everyone, my name is Arham. In this video, we will look at the fundamental concept of clustering and types of clustering methods. Clustering is grouping data points and creating partitions based on similarity. If two things are similar in some ways, they often share other characteristics. Almost everything we perceive is in the form of clusters. When we look up at the night sky, we see clusters of stars and we name them after shapes they resemble. Similarly, a cluster is a set of similar data points or a set of points that are more similar to each other than to points in other clusters. It is classified as an unsupervised learning technique. And the key difference from other machine learning techniques is that clustering does not have a response class. After grouping observations, a human needs to visually look at the clusters and optionally associate meaning to each cluster. The ultimate prediction is the set of clusters themselves, and this technique works only with data that is in numeric form. This means that any categorical variable needs to be converted to a numeric variable by binarization. This is popularly known as one-hot encoding. There are many methods to predict clusters by calculating similarity. And I will now introduce you to 4 different types of clustering methods. First one is centroid-based clustering. Each cluster is represented by a centroid which derives clusters based on the distance of the data point to the centroid of the clusters. One of the most widely used centroid-based algorithms is k-means.
So there is no audio.
The second one is
Yeah.
connectivity-based clustering.
Okay. Acha, then it is not taking the audio from video, I think.
The clusters are defined by grouping
now
the
it's
nearest
okay.
neighbor based on distance between the data points. The idea is that nearby data points are more related than other points farther away. The key aspect is that one cluster contains other clusters. Because of this structure, the clusters represent a hierarchy. This method works in 2 ways. It either starts from the smallest cluster. At each step, 2 clusters that are similar are combined into a bigger cluster in a bottom-up manner, or starts from the biggest cluster. At each step divides into 2 in a top-down manner. Clusters are represented by a dendrogram here, which explicitly shows the hierarchy of clusters. The third one is distribution-based clustering. In this method, each cluster belongs to a normal distribution. The idea is that data points are divided based on probability of belonging to the same normal distribution. It is similar to centroid-based clustering, except that distribution-based clustering uses probability to compute the clusters rather than using the mean. The user needs to define the number of clusters. This method goes through an iterative process of optimizing the clusters, and a popular example is expectation maximization algorithm, which uses normal distribution for clustering the data points. The fourth one is density-based clustering. Clusters here are defined by areas of concentrated density. This method begins by searching for areas of dense data points and assigns those areas to the same clusters. It is based on connecting points with certain distance. A cluster contains all linked data points within a distance threshold, and considering the sparse areas as noise or borders between clusters. I will now go through some clustering weaknesses. In most clustering methods, we need to supply the number of clusters. We can use an approximation method to estimate the number of clusters called as elbow method. Lastly, remember that clustering algorithms are always sensitive to outliers. When you search for something on Google or go onto Amazon to buy something, you're presented with links or products that are relevant to your search by means of clustering. All of the methods we looked at today boil down to the basic idea that we want to find groups of similar objects. If you have any other topics you'd like us to cover, leave a comment down below. Give us a like if you found this useful, and if you want to see more, check out other videos.
Yes, so this is about clustering, where we basically, uh, when we plot data, one variable will be on one axis, say x-axis, and the other variable will be y-axis, and we will have this kind of a plot, which you can call it scatter plot also. Now, the target here is to group data, similar data together. So now you can see blue color, red color, and yellow color, but they are not there initially. Yeah, initially we do not know which data points to group together. So here the problem is to find a criteria to be able to group similar data points together. So that is based on a few methods, as he mentioned. One of the methods is selecting, first specifying the number of clusters we want. He mentioned it as a drawback also. In clustering method, the user has to ultimately decide how many cluster will be there, how many clusters are making sense. Yeah, generally that is the case. So with that, we start with random points. Yeah, say three. We want three clusters. We will select three random points and calculate the distances of all these past data points we have from those three random data points. And each past data point, depending on to which of those random three data points a given point is nearer, it will be put in that cluster. So like that repeatedly it is done. We will see a small example in the next session. Yeah. So right now, the two of the methods he mentioned, k-means clustering and hierarchical clustering, or hierarchical clustering. Yeah, depending on, I mean, there are probably more than one way to pronounce that. Uh, hierarchical clustering. Yeah. So hierarchical clustering and k-means clustering. Yeah. So these two we will go a little deeper into. So k-means clustering is actually more common. So let me move it ahead in the playlist. Yeah, introduction to clustering, k-means. Yeah. So let's look at k-means clustering, what it means, and then we will look at hierarchical clustering. The word dendrogram he used, what is that? Let us try to understand that.
StatQuest, 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 StatQuest. Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about k-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for k. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1. Select the number of clusters you want to identify in your data. This is the k in k-means clustering. In this case, we'll select k equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for k, but we'll talk about that later. Step 2. Randomly select 3 distinct data points. These are the initial clusters. Step 3. Measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4. Assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to Step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster, using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The k-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since k-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change.
Okay.
You are on mute.
Yes, sorry. Yeah, so this was the first iteration. So we had seen the second iteration also. So in the first iteration, randomly 3 points, these big circles are points. For simplicity, all the data is considered on a line. Yeah, lying on a line. Yeah. So these 3 initial points, the bigger circles are chosen. Then from those points, distance of each of the data. These smaller circles are data points. Distance of each data from these randomly chosen points are measured. And see, this dark blue data point is closest to the randomly selected blue circle. So it will be in that cluster, the cluster of the big blue circle. Similarly, these 3 clusters are found out. Then at the end, the variance of within the group. Yeah. So what will happen is we will do this. So we will do this once. So distance of each point in the cluster from the randomly chosen point will be found out, and it will be squared. So it's like a variance. Yeah. So in these first two clusters, there is only 1 point. Here, the variance, like the variance we find out in any data set, you can find out the variance, which is the square of standard deviation. Yeah. So similarly, considering this point as the mean, we find out variance in each of the clusters. Then what do we do is, what do we do next is, now, yeah, so this is the first iteration. Now this is the second iteration. Now the randomly chosen points are different. Yeah, we will again do the same process. At the end, we will calculate the variance within the clusters, and we will keep doing this till we get variance within the cluster same in 2 iterations. Yeah, after this second iteration, we will again, if say the variance is not constant compared to the last iteration, we will do the same iteration again. We will choose 3 different points. Next time, in the third iteration, we will choose still different points, 3 different points, and calculate the distances from each of the data points, group the data points with the nearest randomly chosen point and call it a cluster. Then within the cluster, we will calculate variance and see if this variance compares with the previous iterations variance. Yeah, so at one point of time, the variance becomes stable. Yeah, more number of iteration. After that, no matter uh, no matter which location you choose the 3 randomly chosen points, the variance within the cluster will not change. Yeah. So till that point, we keep iterating this process and ultimately find the clusters. So let us see what further he has to say.
Calculates the mean of each cluster and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, k-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall. So it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for k? With this data, it's obvious that we should set k to 3, but other times it is not so clear. One way to decide is to just try different values for k. We'll start with k equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try k equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the 2 clusters to k equals 1. Now try k equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the 3 clusters to k equals 2. Now try k equals 4. The total variation within each cluster is less than when k equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before. And when there is only 1 point per cluster, the variation equals 0. However, if we plot the reduction in variance per value for k, there is a huge reduction in variation with k equals 3, but after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick k by finding the elbow in the plot. Question: how is k-means clustering different from hierarchical clustering? K-means clustering specifically tries to put the data into the number of clusters you tell it to. Hierarchical clustering just tells you, pairwise, what 2 things are most similar. Question: what if our data isn't plotted on a number line? Just like before, you pick 3 random points. And we use the Euclidean distance. In 2 dimensions, the Euclidean distance is the same thing as the Pythagorean theorem. Then, just like before, we assign the point to the nearest cluster. And just like before, we then calculate the center of each cluster and recluster. Bam! Although this looks good, the computer doesn't know that until it does the clustering a few more times. Question: what if my data is a heat map? Well, if we just have 2 samples, we can rename them X and Y. And we can then plot the data in an XY graph. Then we can cluster just like before. Note, we don't actually need to plot the data in order to cluster it. We just need to calculate the distances between things. When we have 2 samples or 2 axes, the Euclidean distance is the square root of x squared plus y squared. When we have 3 samples or 3 axes,
Okay, so the heat map thing we can discuss when we are discussing it again. Yeah, so basically what we did, this sort of iteration, you understood, we keep on iterating. So the major part is how to choose the number of clusters. That is what is K. K is basically the number of clusters. So how to choose, how to stop, yeah, when to stop. So for that, we draw this graph, that is number of clusters. While doing the iterations, choose choose different number of clusters and say with 2 clusters, 3 clusters, what is the reduction in variance? Reduction in variance is the lower lines you can see with K, what is the variance? Total variance. Yeah. With K2, what is the total variance? That is sum of variance from each randomly chosen point, yeah, which is making the clusters. Then K equal to 3, when we are making 3 clusters, that is we have chosen 3 random points and we are calculating the distances of data points from those 3 points. So there are 3 clusters. What is the total variance? That is sum of variance in each cluster. So you can see as number of clusters increase, the total variance is going down. You can see in the
comparing the total variance,
yeah, in the bottom, these lines K1, K2, K3. So if we plot that number of clusters and reduction in variance, we get a sharp turn somewhere. It will happen. Yeah, somewhere we will get a sharp turn. So that turn is called elbow point. So that elbow points decides. So in this case, you will choose 3 clusters because the elbow point is against number of clusters equal to 3. That is on the x-axis. So elbow point is against that. So in this case, we will choose 3 clusters or stop at 3 clusters. Okay, that is how number of clusters is chosen. So this is the simplest explanation of K means clustering. K means clustering. K simply means the number of clusters. That's all. Now, where are these clustering methods used? Yeah. They are used for, say, market segmentation. Yeah. Which all segments of a market we should have, or say product portfolio, deciding product portfolio, which types of products, which variations of products we should have, how many variations of products we should have. Yeah. So all these decisions are taken from, of course, the past data by clustering the data. Yeah. If we see past data can be clustered in say 5 ways, and we are looking at customer type data, yeah, types of customers data. So we know that 5 segments of customers we can make, and depending on that, if we want product portfolio should also have 5 variations of our product. So for such things, clustering method is used. So one of the clustering method is K means clustering. Then one more A little less popular but equally good method is hierarchical clustering. So it's a little bit
Sir,
longer video.
sir, I have one question. Just so,
Yes.
in this K means clustering, what we understood is like the number of clusters is typically taken as three, right?
No, no,
Uh,
not three. In this case, it is three. It is called
okay.
K. Number of clusters is called K.
Yeah.
How many
o-
clusters you will have to take, it will depend on that this elbow point.
Okay. Okay. Okay.
Yeah. If this elbow point was here somewhere to the right and over 5, then we would have decided to have 5 clusters.
Okay. Okay. But sir, is this also depend on the data size? I mean, now, for example, we have taken 10 data points, right?
Yeah. Yeah.
Versus like 10,000 data points
Yes, yes. It will depend on the size of
size.
data, and
Yeah.
ultimately, the call is to be taken by the user or the analyst. Yeah, how
Okay.
many clusters will be more
Okay.
suitable? Yes.
Okay. Okay. Yeah. Got it. Thank you.
So this is the process of uh, k-means clustering. Now hierarchical clustering. So this person starts singing and little bit some typical exclamations. That bam is when you're surprised. In comic books, you would see bam. So he also speaks in such a way. So yeah.
Going on a quest, on a stat quest, stat quest. Hello, and welcome to StatQuest. Today we're going to be talking about hierarchical clustering. Hierarchical clustering is often associated with heat maps. If you're not already familiar with what heat maps are, just know that the columns typically represent different samples, and that the rows typically represent measurements from different genes. Red typically signifies high expression of a gene, and blue or purple means lower expression for a gene. Hierarchical clustering orders the rows and/or the columns based on similarity. This makes it easy to see correlations in the data. For example, these samples express the same genes, and these genes behave the same. On the left, we have a heat map without hierarchical clustering, and on the right, we have a heat map with hierarchical clustering. So you can see that the clustering makes a big difference on how the data is presented. Heat maps often come with dendrograms, so we'll talk about those too. Let's get started. We'll start with a simple example. Here we've got a simple heat map that has 3 samples and 4 genes. For this example, we are just going to cluster or reorder the rows or the genes. Conceptually, the first step is to figure out which gene is most similar to gene number 1. Genes number 1 and 2 are different. We can tell because the colors are very different. Gene 1 is highly expressed in sample number 1, so it has a red color. Gene 2, however, is not highly expressed in sample number 1, so it has a blue color. In sample number 3, gene 1 is lowly expressed, so it's blue, and gene 2 is highly expressed, so it's red. Genes 1 and 3 are similar, so that means in sample 1, both gene 1 and 3 are red, they're highly expressed, and in sample 3, they're both blue, meaning they're lowly expressed. Genes 1 and 4 are also similar. However, gene number 1 is most similar to gene number 3. So the second step is to figure out what gene is most similar to gene number 2. So we do all the comparisons and we see that gene number 2 is most similar to gene number 4. And then we do the same thing for gene number 3 and then gene number 4. In step number 3, we look at the different combinations and figure out which two genes are the most similar. Once we've done that, we merge them into a cluster. In this case, genes number 1 and 3 are more similar than any other combination of genes. So genes 1 and 3 are now cluster number 1. Step 4, go back to step 1, but now treat the new cluster like it's a single gene. So in step 1, we figure out which gene is most similar to cluster number 1. Cluster number 1 is most similar to gene number 4. And we figure out which gene is most similar to gene number 2. In this case, gene number 2 is most similar to gene number 4, but notice that we compared gene number 2 to cluster number 1. And then we do the same thing for gene number 4. Of the different combinations, figure out which two genes are the most similar. Now merge them into a cluster. In this case, genes 2 and 4 are the most similar combination. So we've merged them into a cluster. Now we go back to step 1. However, since all we have left are two clusters, we merge them. Bam! We're all done. Hierarchical clustering is usually accompanied by a dendrogram. It indicates both the similarity and the order that the clusters were formed. Cluster number 1 was formed first and is most similar. It has the shortest branch. Cluster number 2 was second and is the second most similar. It has the second shortest branch. Cluster number 3, which contains all of the genes, was formed last. It has the longest branch. Now let's go over a few nitpicky details. Remember the first step? Figure out which gene is most similar to gene number 1? Well, we have to define what most similar means. The method for determining similarity is arbitrarily chosen. However, the Euclidean distance between genes is used a lot. Let's look at an example. We'll use a very simple heat map that just has two samples and two genes. Now we're displaying the values that underlie the colors that we have in the heat map. The Euclidean distance between genes 1 and 2 is just the square root of the difference in sample number 1 squared plus the difference in sample number 2 squared. Here we'll just plug in the values for sample number 1. We have 1.6 minus negative 0.5. Now let's plug in the values to calculate the difference in sample number 2. We have 0.5 minus negative 1.9. Doing the subtraction gives us the square root of 2.1 squared plus 2.4 squared. We can think of these values within the parentheses as sides on a triangle. So on the x-axis, we have the distance between gene 1 and gene 2 in sample number 1. And on the y-axis, we have the distance between gene 1 and 2 in sample number 2. The hypotenuse is the distance between genes 1 and 2. The Pythagorean Theorem says that the hypotenuse equals the square root of x squared plus y squared. In this case, that means the square root of 2.1 squared plus 2.4 squared. And that gives us 3.2, the distance between gene number 1 and gene number 2. When we have more samples, we just extend the equation. It's no big deal. The Euclidean distance is just one method. There are lots more, including the Manhattan distance. The Manhattan distance is just the absolute value of the differences.
So this is the basic concept of hierarchical clustering. So one by one, we try to find out which uh, sample or which gene is closer to the other sample or other gene. And if we find them to be very similar, we keep on clustering them together. Of course, here the end point is clustering everything together, which does not make sense. So somewhere in between, we have to decide when to stop doing this clustering together. Okay, so that is hierarchical clustering, basic of hierarchical clustering. So we will discuss all these methods, these four methods. Basically, we have discussed four methods: decision tree, uh, regression, neural networks, artificial neural networks, and now clustering. Okay, so one by one, we will see simple examples and we will try to work out simple examples of some of them, yeah, some of these four methods. Okay. So today, let us try to work out an example of decision tree. So these four methods we got introduced to. I have put together this playlist, yeah, which is quite enough. It's a good playlist, I would say. Yeah, a wholesome playlist. So you can watch this. It has 13 videos, and only this one video is a little long of 1 hour. Others are about 10 15 minutes videos. So at least once you try to watch, even if you skip this 1 hour video, it's fine. So please at least watch the rest of the videos at least once. Yeah, it will give a very good picture. And after everything is done, again watch these videos. After we have discussed in the class, worked out some examples, again have these videos. Yeah. So again have a look at this videos. So let us now see a decision tree data. Yeah. So this is the data. Of course, you do not see any tree here. So this is how the data is there. Yeah. So what it is showing is these outlook, temperature, humidity, windy, these are called features. Okay, these are called features in the data. And the last column is the decision column. So here in this case, the decision is to play, say play tennis or not. If it is a sunny day, temperature is hot, humidity is high, and it is not windy, then the person decides not to play tennis. So play is no. Similarly, various different combinations are given. Yeah. But not all combinations will be available. In real life, not all combinations will be available from past data. Now, suppose given this data, we have a combination like this. Yeah. So now we have a combination of, say, I'm taking an example from a book. So we have outlook, temperature, humidity, windy, and play. So suppose we have a combination like this. It is sunny on that day. Temperature is hot. Humidity is normal. Windy is true. It is windy. Then whether the person will decide to play or not. Yeah. So this is the type of question we would answer. We would try to answer through decision tree. Again, this is basically a classification, play or not play. Yeah, depending on the previous past data we have. So we are trying to classify the situations into play or not play. Yeah. If you see, this particular combination is not there in this entire previous data, this data set. I'll share this data set in chat so you can save it on your computer also. Yes, so it's a 2 MB picture, JPEG picture. You can save that. You can refer to that in between. So you can see this sunny, hot, normal, true. Sunny, hot, normal, true is not there. Sunny, hot, normal, true is nowhere there. Yeah, so we will try to prepare a decision tree based on this past data and try to answer this question. Yeah. So what do we basically do? Okay. So first is to decide which feature to begin with. That we will call as root node. Whether to begin with outlook, temperature, humidity, or windy. So what I am saying is, we you have seen a decision tree. Uh, yeah. So what will be the starting point of this decision tree? At the top, which feature we should put? So for that, what we do is we try to find out a metric. Yeah. We try to find out a metric. So for root node, what we do is say one by one we will do. This is the problem. Yeah. So one by one for each feature, we will find out a metric which will show without any confusion in how many cases a clear play decision is there in the past data. What I mean is I'll work out an example and work out this example and we will see. So one by one we will see. So first feature is outlook. Yeah. So rules in outlook. Yeah. So we have to take one by one. Say sunny we take. Sunny we take, and we say that when it is sunny, the decision is no. Then what happens? If we put that as a rule, sunny and no, the play decision is no. Then what will happen? How many times we will be correct? Sunny and decision no. Here sunny, decision no. Here sunny, decision no. Yeah. Here sunny, decision no. Here sunny, decision yes. So we will be wrong here. And here sunny, decision again yes. So sunny, sunny, sunny. Yeah. So there are five sunny. 5 times outlook was sunny. And if we put this rule, sunny equal, if whenever it is sunny, we say the decision will be no, we are right how many times? Sunny, no, sunny, no, sunny, no. So 3 out of 5 times, 5 sunny. In that 3 times we will be right. Yeah, so the error will be 2 out of 5. Correct. 2 out of 5. Okay. So it actually calculates. That's okay. So this will be, yeah. So this will be when sunny, we say we are considering sunny and we are taking this rule as sunny will lead to no. Now, outlook is not only sunny, it is, there are option of overcast and rainy. Yeah, so there are 3 options. Outlook could be outlook in the sense weather. It gives an indication. It gives a uh, hint that whether is sunny, overcast, or rainy. Okay. For that, outlook feature is used. Outlook word is used in this case. Yeah. So for sunny, we did that. For sunny, we stuck to a rule, and we uh, got this error. Yeah. So why a sunny no and why not sunny yes? Because if we say sunny yes, we see that the error will be more. Yeah, that will be, we will be wrong 3 times. So we are trying to minimize the error. So we are choosing the better alternative. If we choose the rule sunny means no, if we directly say that, we will be wrong 2 out of 5 times. Yeah. So in that way, we choose this rule and not sunny means yes. Yeah. But sunny is not everything in Outlook, not all the options in Outlook, as we just saw. It could be overcast also. Could be overcast. So overcast. So in overcast, how many times it is yes, how many times it is no, let us see. So this is overcast, this is overcast, this is overcast, this is overcast. So 4 times overcast is present. So overcast, yes, overcast, yes, overcast, yes, overcast, yes. Okay, so there is no confusion. So if we say overcast means yes, there will be no errors. Yeah, none of the times we will be wrong. So error will be 0 divided by 4. 4 times overcast is there, and we are choosing the rule overcast means yes. So we will never be wrong. Yeah. But again, overcast is not everything. There is rainy also. So in Outlook itself, we are considering just one feature uh, right now. We are doing all this to first decide the root node where the decision tree will start. So let us see rainy, how does it look? So rainy, yes, rainy, yes, rainy, no. Then there is, this is the 4th rainy, yes, 5th rainy, no. So rainy is more yes, more number of times it is yes. So if we choose that as a rule, rainy, if we directly say rainy means yes, then how many times we will be wrong? Rainy, yes, that means correct. Rainy, yes. Rainy, no. Rainy, no. And rainy, yes. So 2 out of 5 times again, we will be wrong. 2 out of 5 times. 5 times. So total error will then add everything. Yeah, it will be 2 by 5, 0 by 4, and 2 by 5. So it comes out to be 4 by 14, 0.28. Yeah. Yes. So if we add this also, it should come somewhere near to that. Yeah. No, no, no. These are not with the same denominator, so we cannot add them. So we are adding the all the errors, all the number of errors. Here there are 2 errors. Here there are 0 errors. Here there are 2 errors. So errors in the numerator we are adding, that becomes 4, and errors in the denominator we are adding 5 plus 4 9, 9 plus 5 14. So we are calculating 4 by 14 is the total error. Yeah. So this will be a mistake if we just add this error. Yeah, add these 3 errors. So please be careful that we will be adding the numerators separately and denominators separately. So out of total number of cases, how many errors will be there if we choose this rule? This will be the minimum number of errors in Outlook. Yeah. We will do the same thing with temperature. Now, would you like to do that or attempt that? You have you have this pick, you have this table temperature. So temperature, how many possibilities are there? Just have a look. Hot, mild, cool. Hot, mild, cool. Yeah. So if we first pick hot, yeah, let us see where the error is less. So hot, no, hot, yes, hot, yes. So it's a 50-50 case. So we can arbitrarily choose hot, say we choose no. So out of this 3 plus 1, 4 hot, we will be wrong 2 out of 4 times. Actually, it is better to keep it as text as we are not going to add it anyway, add the result anyway. Yeah. Okay. Hot, no. Then there are other three possibilities: hot, mild, and cool. Mild. Again, let us see where the error is less. Mild, yes. Mild, no. Mild, yes. Mild, yes. Mild, yes. Mild, no. So 4 times, if we say mild yes, if we choose the rule mild yes, 4 times we will be correct, and only 2 times we will be in error. 2 out of 6 times. Then there is also cool. Cool, similarly, we will choose a rule. Cool yes, cool no, cool yes, cool yes. So more yes. So we will choose that as the rule. And if we choose that as a rule, how many times we will commit a error? So this cool no. All other cool are yes. So we will be wrong 1 out of 4 times. Yeah. So then again, we will calculate the total error, which will be 2 plus 2 plus 1, that is 5, divided by again 14. Yeah. 4 plus 6 plus 4, 14. Yeah. Similarly, we will do with humidity. Yeah. So humidity is how many possibilities are there? High, normal, high, normal. So there are only 2 possibilities. Yeah. So let us take high.
So this sum is correct because the
Sorry.
sum for this temperature, we have to
Yeah.
directly sum it, or we have to, because
No, we
denominator
cannot
is not.
directly sum it. We will sum the numerator together and denominator together. Then we will divide the sum of numerator divided by the sum of denominator. So basically, we are trying to calculate how many times we will commit a error. Yeah.
Okay.
So it is 2 plus 2, 4 plus 5. 5 times we will commit an error. Out of total, how many times? 4 plus 6 plus 4. That is 14. So that becomes 5 divided by 14.
Okay.
These many times we will commit a error. Okay. Yes. So humidity can be high or normal. So which rule will lead us to least error? High no, high yes, high yes. So 50-50 till now. High no, high yes, high no. So I think if we say high no, then we will have high yes, high yes, high yes. So three three times we will be wrong out of total 7 times. Yeah. So high no. If we choose this rule, we will be wrong only 3 out of 7 times. Yeah. Then if humidity is normal, you can see here normal yes, normal no, normal yes, normal yes, normal yes, normal. Definitely normal yes has to be the rule. And if we choose that rule, we will be wrong only once. Only once it is normal no. Otherwise, it's all normal yes. Whenever humidity is normal, the person decides to play. Yeah. So only once we will be wrong if we choose normal yes as a rule. Yeah. So this is done. Humidity has only high and normal. So if we add that again the same way, 3 plus 1 will be the numerator. That will be 4 divided by 14. So let's see. Already there is a tie. Now if the other this thing, other feature, windy gives a score less than 2.8, then will be choosing that as the root node. So we are trying to minimize the error. Whichever feature calculating the errors like this will give the least total error, we will choose that as the root node. Okay. So windy, if we see windy, how many possibilities are there? False and true. Okay, so let's start with false. Now again, false, no, false, yes, false, yes, false, yes, false, no, false, yes, false, yes. Definitely false, yes should be the rule so that we commit least error. If we do that, we say that only 2 out of 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 8 times there is false, and only 2 out of them is no. So we will, if we choose false yes as a rule, only 2 out of 8 times we will be wrong. Similarly, if we consider windy as true, yeah. So what is happening in this case? Windy, true, no, true, no, true, yes, true, yes, true, yes, true, no. So yeah, so again there is 50-50 chances of uh, decision yes or no. So let us say we choose true as no. So it will give us a error of 3/6. This was 2/8 and 3/6. So this will again give us a total score of 2 plus 3, 5 divided by 8 plus 6, 14. Okay, so there is a tie. Of course, there is a tie between humidity and outlook. Humidity and outlook. So in that case, we will prefer a node, prefer a feature which has some pure element that is where the error is zero. Here in humidity, in none of the possibilities, error is zero. But here we have this overcast equal to yes as a pure element, we call it. So we will prefer outlook to be the
So why can't we choose temperature and then windy?
temperature's error is more.
Okay.
These
So
error,
we have to choose which is where is the less error.
yes, where is the least error? We have to choose this column. We have to see in this column wherever there is least error. We have to choose that. Yeah. So in outlook and humidity, there was a tie. Both had 0.28 error, but there is a pure element here where there is no error. Yeah. So we will go with outlook. Outlook as the root node. Let me try to draw the tree in a different sheet. Outlook. Yeah. So what we will do next is yeah. So we have decided to split this data starting with the root node outlook. So outlook has sunny, overcast, and rainy. Yeah. So as we have decided outlook to be the root node, then we will be splitting this data into sunny, overcast, and rainy. Sunny, overcast, and rainy. So if we say it is sunny, then what happens? So if it is sunny, then outlook, of course, under outlook, we are saying sunny. So what happens to the temperature, humidity, and wind? Yeah. So in sunny, we will again draw a table. temperature, humidity, yeah, and windy. And of course, the decision play yes or no. So now we have to extract this data. How many times sunny is there? Sunny, 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 sunny. Yeah, so only sunnies we will see. So once it is hot, temperature is hot, again hot. Where is sunny again? Yes, here is sunny and temperature is mild. Then this is done sunny, cool. And any other sunny? Yes, sunny, mild. Yeah. Now here we can just copy the humidity, high, 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 normal, normal. High, high, high. Three are high, the bottom two are normal. We are concerned with only sunny here in this part of the tree. This is not becoming an actual tree. Yeah, this is becoming a interim table. Now in windy against sunny, what is there? False, true, false, false, true. Yes. So false, true, false, false, true. False, true, false, false, true. Give me just uh, half a minute. I think there is a neighbor. There is Eid today, so I'll just uh, meet him for half a minute. Yes, yes. Sorry. So there were some celebration in the colony, and there was no light, so everybody had uh, kept to their own houses. Now they are sharing gifts and other things, which is very good in Eid and Akshay Tritiya. Yeah. So yeah. So where will be windy? So windy table we have copied here. Then play for sunny we will copy. Yeah, sunny no, sunny no, no no no, yes, yes. So four no and one yes. No and yes. Yeah. So that happens when outlook is sunny. What happens when outlook is overcast? When outlook is overcast, every time we play. Yeah, overcast, yes, overcast, yes, overcast, yes. Yeah. So overcast, when the tree comes to overcast, the only decision is play. Yeah, that is yes. So we do not have to do anything else here. Yeah. So if it is overcast, there is nothing to see what is the temperature, what is the humidity, what is the windy. The person will play. Okay. So that is that becomes a very short branch. Now, if it is rainy, again, like sunny, we will have to see what all things are there. So again, there is temperature, humidity, and play, definitely. But this time we will focus on when it's rainy, only when it is rainy in the original data. So rainy is mild, high, false, yes. We can also copy like that. Mild, high, false, yes. One rainy done. Second rainy, cool, normal, false, yes. Cool, normal, normal, false, yes. Third rainy, cool, normal, true, no. Cool, normal, true, no. Cool, normal, true, no. Then rainy, fourth rainy, where is, yeah, mild, normal, false, yes. Mild, normal, false, yes. And there is a fifth rainy at the end. Mild, high, true, no. Mild, high, true, no. Okay, so this is now the table. These bullet form got automatically done. Yeah. So these are the tables now. From this original table, we have reduced it to this now. Yeah. Still, they need to be reduced further. Now what we will do in sunny, we have temperature, humidity, windy, play. Play is a decision. So we have temperature, humidity, windy. Okay. So like we did here for all the features, outlook, temperature, humidity, windy. Here we will do only for this table. Yeah. what we will do, if we take temperature, then what are the outcomes? Hot, hot. What are the outcomes? Hot, mild, and cool. So first for hot, again I can copy that uh, column heading, attribute, rules, error, and total error. For temperature is now an attribute. Yeah. So rules is, if we see uh, hot, yeah. So hot, no, hot, no. Yeah. So hot, no definitely becomes the rule, and error will be 0, 2. If we say hot means no, temperature, if hot, the person will not play. Yeah, hot means no. Then the error is, we are never wrong. So the error is 0 by 2. Yeah. Understood this? Then what we will do, you can guess. We will check for mild. So mild, no, mild, yes. So either you can take, say, you take mild as no. So if we say mild as no, then we will be wrong once. So mild as yes is there once. So we will be wrong 1 out of 2 times. Then what are the other possibilities in temperature? Cool. Which rule we will select for cool? Okay, cool is no, only once is there. So cool we will definitely select no, and we will say that we will be wrong 0 times. This is 1 by 2. 1 by 2. Achha. Okay. Now total error, numerators we will add 0 plus 1 plus 0, that is 1, divided by 2 plus 2 plus 2, that is 5. Yeah. So 2 by 5. Then humidity. Next attribute is humidity. Humidity is, what are the possibilities? High and normal. So first we take high. What should be the rule? Humidity is high. No, high, no, high, no. Okay. Very simple. Then all the times it is no. So we will make that as rule, and we will say our error will be 0 times, 0 by 3. Then only the other possibility is normal. What should be the rule? Okay, 50-50. Once it is yes, once it is no. Let us take, say, yes, we have been taking no all the time in a tie. Let us take yes this time. So we will be wrong once. So the total error will be 0 plus 1. No, no. Yes. Yes. So total error will be 0 plus 1 numerator, that is 1 divided by 5. This is humidity. Normal is no, normal is yes. Sunny, let me check. Sunny, yes. Okay, this is last two sunnies are yes, and the first three sunnies are no. Okay. Yes. Even better, if we now choose normal yes, then we will not be wrong anytime. So total error is actually 0 in this case. 0 divided by 5. So you can guess, we probably don't even have to do for the next attribute, that is windy, but still we let us do, because this is the first example. So windy, what are the possibilities in windy? Windy can be false. Yeah, let us write false. What should be the rule? False no, false no, false yes. So 2 times no, 1 time yes. So we will choose false as no as the rule. False as no as the rule. And then we will be committing an error 1 out of 3 times. So it is false 3 times, and only once it is yes. So we'll be committing an error 1 by 3. One by 3. Yeah. Then what are the other possibilities in windy? It is true. True. Yeah. So true as no will take. True as no if we take, we will not be committing any error. So it will be 0 by 1. Did we make any error? True. Okay, there are two truths. If we say true equal to yes, yeah, true equal to yes or true equal to no, either way it is 50-50. So we will be committing an error 1 times out of 2. So the total error will be 2 out of 5. definitely our next node will be humidity. Yeah. In the sunny part, so under sunny, if we have this, so under sunny, the first attribute we will have is humidity. We will have humidity as the attribute. And the possibilities are when it is humidity is high or normal. Okay. So sunny and humidity is done. Similarly, we will have to calculate a couple of more tables. One table actually, only one table. Yeah. For rainy. Here we had rainy. Yeah. So sunny part is done. So now we can focus on rainy. You can make it of a different color if you want. Yeah. Yes. So in rainy, what we will do again, attributes rule, this thing. So again, what are the attributes here? Same, temperature, humidity, windy. Yeah. So we will calculate for the three. Temperature, humidity, and windy. So if we do that, you can do that one by one. So temperature again, yeah. Okay. So temperature here it is mild and cool. Only two types are there. So mild, yes, yes, no. So we will keep mild, yes. 2 out of 3 times it is yes. So error will be 1/3, and cool will be just to show that there is no hot here. Yeah, of course, rainy and hot doesn't seem feasible, although it can happen. So cool, what rule we should use? 2 times it is there, once it is yes, once it is no. So either one we can take. Cool yes if we take, so we will get 1/2. Mild yes, 1/3. Cool yes, 1/2. In humidity, if we see, humidity has high and normal. So first, if we take high, and keep the rule as no, we will be committing an error 1 out of 2 times. Then if we take normal and put the rule as normal is yes, we will be committing an error 1 out of 3 times. Yeah. Now windy is how many? Okay, there is yeah, there is 3 false and 2 trues. So let us take false first. If we put the rule false equal to yes, we are committing an error 0 times because all the false, you can see all the false are yes. False is false is false is. And true is no once and true is no twice. So again, we will put the rule true as no. Then again, we will be committing an error 0 times. So here, even if we don't total, we know that windy is going to be the next rule. Next node. Yeah. Okay. So 0 error here. Here also 0 error. So as we are reaching this 0 errors, these are called leaf branches. So if we have reached 0 errors in all the possibilities, then we should stop the tree. We can stop the tree. The total error will be 0/3. In all the possibilities, right? Here also we had reached a 0. No, earlier we had not reached any 0 at all. But some, if in some attribute we are reaching 0 and others we are not reaching 0, then it doesn't work. Yeah. Yes. So humidity and windy. Yes. So what we will do here, humidity high normal and rainy, we will split on windy. So windy has how many possibilities? Here, windy has false and true. False and true. Okay, false and true. So this is our tree. Yeah, humidity is high. Then what will be the humidity equal to high is the rule, and normal is as yes is the rule. Yeah. Humidity high, no. Normal, yes. So this is the final uh, node. This is one leaf node. This is another leaf node. Then if windy is false, windy is false, then yes will be the rule. Yes will be the rule. And if windy is true, then no will be the rule, because it gives zero error. Again, these are the leaf nodes. Now let us see if we can have a solution of the problem we started with. So where is the problem? This is the problem. This is the outlook sunny, temperature hot, humidity normal, windy true. So outlook sunny. So it will come to this branch. Temperature is hot. There is no temperature. Okay. So we will skip that. Humidity is normal. Humidity is normal. So we come here. Then windy, we again do not have. So our answer will be yes. So answer is, let me write it here because we found that. So after drawing the tree, it's not that all the attributes will be there in that branch of tree, but we do not stop because some attribute is not there. For example, temperature is not there and windy is not in this branch. But what we have, we go with that. We use that. Yeah. So outlook is the first branch. We immediately come to sunny. Then temperature we do not have, so we do not have to worry about that. But whatever be the temperature, it will be the outcome will be same. Yeah. Humidity is normal. Humidity is normal. And again, windy we do not have. So it doesn't matter if it is windy or not, he will play. Once it is sunny and humidity is normal, our decision tree shows that the person will play. So this is the answer. And for this, we took all this trouble. So you can draw arrows. You can draw arrows from outlook to sunny, outlook to overcast, outlook to rainy. Okay, I think one person even dropped off, but it's all right. So this is about decision tree. Of course, there are shortcuts to do this. There are softwares, not shortcuts, softwares to do this. So yeah, you can use any software available for free. So this is clear. Decision tree is clear.
Yeah.
Okay. 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 Then yeah. So time is also over. I think yeah.
Can you share this Excel sheet what you have prepared?
Excel sheet. Excel sheet. I'll share.
Yeah.
Yes. Shall I share in chat or on
WhatsApp
TCS
will
IR?
be. Yeah, TCSI one is also okay. Or WhatsApp.
Sorry. Okay, I think I'll share some other way. It is not accepting Excel file in chat.
Yeah, TCSI or WhatsApp. Anyway.
TCS and or WhatsApp. Yes, I'll do that. Yeah.
Yeah.
So next time we will see some other method. Yeah, most probably uh, cluster analysis. Cluster analysis has more things to discuss. The videos of which we saw today. Neural network is hidden. We can understand the mechanism a little better, but this sort of problems with pen and paper we might not be able to do very efficiently, but still we will try to have a relook at neural networks as well. Regression, you already know, but still there are some points which can be discussed. Logistic regression, which is a variation of regression that we will discuss little bit. It's simple. Everything is simple. So basically, in machine learning models, we will focus on these four methods. Yeah. So, what are these four methods? Decision tree, which we discussed in detail today. Probably we won't be discussing decision tree again, but we will be discussing regression, neural networks, and cluster analysis in little more detail. Then our course will be over. Unfortunately, in the last 1 hour only, we got experts for the MDP part as well. Fortunately, so let us see what combination of those experts can cover the parts. Yeah, yeah. So we'll meet again on Saturday, I think. Yeah.
Okay, and then when will be the end term exam?
End term exam will start from 19th May.
Oh, this is too early because we need some time for preparation.
Yes, only a little time. Yeah. So yeah, still we are more or less on track. Yeah,
Yeah,
and the
but
other
we need
subjects as
minimum 1 weekend, 2 weekend for preparation. Otherwise, it is quite difficult because now we are just attending only lectures. We are not doing anything.
yes, that is true. So you can, of course, for midterm you would have prepared a little bit. I mean, the part covered till then. So after that, yes, so you can, you should definitely start your preparations step by step.
Only we don't have
So
time. That's the problem. Yeah, even though we start.
time will have to make time, or the solution is to break down the target into smaller chunks. Even if you start 15 minutes per day for each of the 6 topics, then it is manageable.
Sir, we are human beings. We don't have, and that is also working professional. It's not easy, definitely. So that's the
Yeah,
problem.
working professional.
Because
That is the this is one arrangement. Uh, People are also thinking about making it a weekday evening course, like in Mumbai,
yeah,
many
but they have a
institutes.
weekend off. But we have in Pune University same pattern. Every day there are lectures, but there is no lectures on weekend. So either we have weekdays or either we have weekend. But for us right now, every day is lectures and every day. So very
Yeah,
difficult to get.
but next semester will not be like this. Next semester, uh, weekday lectures will be very less if there are weekday lectures, and yeah, so maybe somebody else will take care of the coordination, but weekday lectures will be very less. Weekend will be most part, and only a limited amount of MDPs will be there. So right now we are doing more MDPs because last semester what happened, nobody took care of that, and it got remained only during the uh, results, etc. We focused on that. We came to know about that. Yeah. So this semester, when it is over in a nice way, next semester should be smoother.
But
The-
if I pass this semester, then only I will able to join next semester. I don't think so because it's quite difficult.
Subjects, is any subject too difficult? Are you finding any subject too difficult?
Yeah, no subject is difficult, but we need
Yes.
preparation. We have to recite
Revision, of
everything.
course.
Yeah, and then now it is not like that we heard in the or we attend the class and everything is in our brain. That time has been gone. That time is past 20 years back for me. So it is not easy. So even though we have to, we need definitely we need a revision to remember everything. Otherwise,
Yes, yes. Even I mean, everybody needs revision. If
yeah,
somebody is continuously working, continuously studying, even a 20-year-old person needs revision. uh, yeah, so our brain works that way. Revision is definitely required. Even we have to revise to teach. Actually, we have to revise more. That is true. But others also, younger people also need revision. Yeah. Important is to understand during the classes and do a little bit of revision. It helps when you write something with your own handwriting. If you make notes, even pictorial notes, they help. They give more confidence also, and it looks more familiar when you revise later. If you write something, some your notes by yourself, yeah. If you make notes, that is to say, if you make notes, it gives more confidence. Yeah. Otherwise, only revision also will not help. Revision plus testing, that is testing yourself. So you have to try to recollect. Yes. Okay. Okay, then we will see.
Okay. Yeah.
Uh, Meet again on Saturday. Yeah. Okay. Thank you.
Okay. Bye bye. Good night.
Thank you.